Chapter 14, Quantum Mechanical Postulates. Section 14.6, Quantum Mechanical Postulate 6. Postulate 6 states that the wave function of a multi-electron system must change sign under the exchange of two electrons. The wave functions of electrons must be antisymmetric with respect to the exchange of the coordinates of any two electrons. Over here, we just label them 1, 2. And the mathematical expression is this: psi of R1, R2 in time equals negative psi R2, R1 in time. Note I just exchanged electrons 1 and electron 2 here. Antisymmetric means changing the sign, and over here the coordinates include the spatial coordinates and also the spin coordinates of the electron. For a time-independent system that consists of two electrons, 1 and 2, we have a simpler mathematical expression. We do not have the time variable t, so the lowercase psi of R1 and R2 equals negative psi of R2, R1. The Pauli exclusion principle is the direct result of postulate 6. No two electrons may occupy the same spatial orbital and have the same spin, because if they did, since electrons are indistinguishable, we would have psi of R1, R2 equals psi of R2, R1. But from postulate 6, we have psi of R1, R2 equals negative psi of R2, R1. So if you compare these two equations, the left side equals this left side, the right side here equals this right side, and therefore psi of R2, R1 equals negative psi R2, R1. Well, if you look at this, psi is negative psi. What does that mean? The only possible solution of this equation is this: psi of R2, R1 is 0, and also psi of R1, R2 is also 0. We just essentially have 0 equals 0, 0 equals negative 0. And then we have the probability density equal to 0. This is because if psi is 0, the squared modulus of psi is 0. And the squared modulus of psi is the probability density. So that means the probability is 0 for finding two electrons with the same spin occupying the same orbital. And that's called the Pauli exclusion principle. No two electrons may have the same set of quantum numbers, or in general, no two electrons have the same quantum state.